spent a lot of time trying to understand how to fit AI inside my workflow, especially when I'm designing architectures as well as with Micro-Frontends in mind. So during this session, we're going to see how these things works. But first, let's start with the bold opinion. You have heard probably several times that AI is going to replace us all. I don't believe it's going to happen very soon. Maybe in the future, maybe they're going to make some amazing discovery and breakthrough into the system. But at the moment, there is quite a lot of things that we can still do with AI. Because I think AI is a fantastic tool that is not going to replace us, but more is augmenting our capabilities. So we need to understand what we need to unlearn in order to make the best out of it. My name is Luca Mezzalira. I'm a serverless specialist in AWS. I'm an orally author, an international speaker, and also a tech content creator. And during this talk, I'm going to share with you 5 tips on how I was able to have AI inside my workflow. It takes a while because obviously the changes are happening very often and they are very quick and usually are quite drastic. So therefore, I need to understand where things fit. Now it seems that I found a good balance. So let's start first, although, to discuss what are Micro-Frontends and why are important. I believe that, in the last 5 years, I helped quite a lot of teams worldwide, roughly 100, implementing Micro-Frontends. The vast majority of the time, the first issue that I've seen with Micro-Frontends is thinking about Micro-Frontend like components. Therefore, they create, for instance, a button and they load at runtime, and this button has a bunch of properties that are exposed to the container. And at this stage, obviously, you will see that if the button has exposing all the properties, it means that the button is not aware of the context, but the containers of the button is aware of the context. So it knows maybe it has a state management, maybe it has a bunch of information or APIs that are fetching while the button is passively there behaving like a button. And this is, let's say, the main difference between a button and a component, and Micro-Frontend, because a Micro-Frontend is something different. It's not just a simple passive component. Micro-Frontend usually, first of all, is less granular than components. You have one or few of them in the same view, and they are encapsulating inside themselves the whole logic. They are completely context aware. You don't have to instruct a Micro-Frontend how to behave. That is the key difference between components and Micro-Frontends. The interesting part here is that also Micro-Frontends are independent. I can deploy them independently, and as you can see here, it's very simple to implement inside your system. Now, the main difference, or why we are discussing about this difference, is that the components have different goals compared to Micro-Frontends. So first of all, they are optimized for reusability. We want to reduce the amount of duplication inside our code. So if you see similar behaviors like a button that we want to spread across our system, we write once and we have all the capabilities there. It's very flexible, and therefore it will leak this domain outside itself. But at the same time, it's great for UI consistency if you think about design system, for instance. Now, Micro-Frontend has a completely different goal. Micro-Frontend is designed for, optimized for independence, so independence of the team as well, because we want to have in distributed system the teams that are communicating less between each other. So we have a faster flow to reach production. They can test more often and more quickly. They can reduce external dependencies, not eliminate them, because obviously it's inevitable that certain things will be shared. But we are going to design a thing in order to have enough, let's say, cognitive load inside the team for building a meaningful part of the system without the complexity of and friction that are, let's say, spread across multiple teams. So Micro-Frontends are definitely different from components because they are diverging in goals. Each of them are expressing different things inside your system. Therefore, you need to be aware how to design these things, because that is usually the main mistake people will start making when they are designing Micro-Frontends. Now, how AI fits with Micro-Frontends. But first of all, we need to recognize that Micro-Frontends is an architecture, and as such, it has two others linked dimension that we need to take into account when we are designing our system. So the organization structure and engineering culture usually are foundational for designing our system, especially distributed system. This is not only for Micro-Frontend, but also for other distributed systems. If you are thinking that an architecture is generating friction, it's just surfacing a fantastic feedback that is saying that the other two dimensions, engineering culture or organization, are not working properly. So either you change the architecture, that's an option, or you change the way how you structure the teams, or you try to understand what are the practices that will enable you to reach the goals that you have in mind with the distributed system. So these three are linked together, and therefore the time that you're changing one dimension, you are probably affecting the other two for better or worse. Therefore, be mindful on that. Therefore, when we are talking about architecture, we need to think that we need to understand our context, these three dimensions, as I said before. Because LLMs or AI is great for providing us best practices, but what are the best practices inside our context? If we don't understand that, you might realize that you are either over-engineering your system, or you are building something that is not what you want to build. So if you think about the software development lifecycle, at the beginning of it, we have a bunch of things that we intentionally are not doing. We define some business requirements, like a feature should look like for a user and how it should behave. We then move into architecture characteristics. We want to load this specific Micro-Frontend in a certain way. And then we move into the design decision. We want to use, I don't know, React as a framework, or we want to use Module Federation for the composition, stuff like that. And finally, we went into the implementation. The first three steps are foundational for the implementation. At some point, you arrive to a situation where these three steps are more stable, but at the beginning of a new project, these things are extremely important. Even at the beginning of specific features that are extremely impactful, maybe span across multiple domains, is extremely important to define them. So my first tip is leveraging context engineering for having a better output of your code assistant and LLM in general. What is context engineering? Luckily for us, what it means is if you are used to do these kind of things before, so the three steps that I described before, you will have a great life in context engineering, because if you're capable to define the business characteristics, the architecture characteristics, and the design decision that you want to have, you're going to have better outcome in your system. The vast majority of the time for expressing that, you use markdown files that are inside your project. So you basically upload them inside version control. And tools nowadays are providing a fantastic way to express your context for an LLM, because again, an LLM is, let's say, providing best practices in general, but not maybe the best practices that are useful for your project. So tools like Kiro, that is a new IDE created in AWS, Cursor, Claude, etc., and there are many other, Visual Studio Code or whatever tool you're using, are providing you facilities in order to express this context. Cursor are called rules, for instance. In Kiro, we have spec-driven development, where you describe your goals and what you want to express for a specific feature, and then it helps you to build that. Remember that nowadays we are moving from writing a lot of code to reviewing a lot of code. Therefore, having clarity of what you want to express helps you a lot in order to understand what are your intentions, and if the code that is generated by the code assistant is the right one for you. So in the case of Micro-Frontends, what usually I recommend is first trying to understand what are the subdomains of your Micro-Frontends. So how you are going to split your system, monolith system, into different chunks. Is it, I don't know, that in an e-commerce you have the FAQ part that is not, let's say, changing very often. Maybe that is a single Micro-Frontend, but in the home page where you have multiple areas that could be latest product, maybe some marketing information, maybe some I don't know, personalized things that you want to show to the user are maybe different domains. Therefore, you want to combine them in a single view, and that might be handled by different teams. So these kind of things, definitely having clarity of that will help a lot. I've also created in 2019 what I call a decision framework. There are 4 decisions you need to make for designing a proper Micro-Frontend architecture, and those are extremely simple. So first, you identify how many Micro-Frontends you want in a view. view, you want a single one that I call vertical split, or you want multiple of them that I call horizontal split. And both of them obviously can be used in the same system, but you need to have clarity on what you want to express there, because if you instruct your LLM with this information, then it becomes easier to have a better output from code-wise. You need then to understand how you want to compose. Do you want to have a client-side rendering application? Do you want a server-side rendering one? So what is the way how you want to handle? Then how you're going to route. You're going to route through a routing mechanism living inside the application shell, so the container of all your micro-frontends. You want to do it on the edge because maybe you are migrating from an old system to the new system, or you want to have on the server-side rendering because you have a server-side rendering application. And finally, how you're going to communicate. Usually micro-frontends encapsulate the state. Therefore, the best way is using custom events or observables or even an event emitter. So those usually are decisions that you need to make up front. You don't have to select everything in one go, but slowly but steadily remember to check that your implementation is respecting the decision that you made. That is extremely helpful. If you map these in Markdown files, then your favorite IDE will provide you a better result. Then we think about the framework to use. Are we going to use in client-side rendering, I don't know, single SPA or module federation or something else? On server-side rendering, we can use, I don't know, Vercel with the latest on Micro-Frontends or Pyral or whatever. So as you can see, there are a bunch of decisions that you need to take and then document for the LLM to work properly. You can define patterns and anti-patterns. Maybe you said that the communication is through event emitter, and therefore forget about custom event and stuff like that. And also code snippet. If you have a configuration inside Webpack or RSPack or ESBuild, whatever you're using, that you want to maintain when you're scaffolding new micro-frontends, you can do that, let's say, sharing this information inside the system. Now, the next thing is thinking like a developer. I don't know why, but I feel every time I scroll my my feeds on social that people forget about that sometimes, and we go straight into, oh yeah, LLM does everything. That's not exactly true. So if we build iteratively, like we are used to do, then probably we're going to have better results. So usually, I've seen prompts like, oh, create this landing page, homepage that contains this, and that. And then you start to iterate on this. But it's by far easier, and you have better results and more control on the code that is generated if you split in this way. So you start to say, okay, I have to build an homepage, and I want to have first the hero component. So create a hero component, you provide a spec for that, and then you move into, okay, now we want to have the bestseller products, and you select that, and so on and so forth. If you iteratively do, like you would do when you are writing code, you start maybe first from the UI part, and then you move into the API that you want to call, or vice versa. So whatever is your technique, try to apply exactly the same thought that you are using, and maybe bundle some of them in order to, let's say, reduce the prompt fatigue. But in reality, it becomes quite easy. So prompt like this, like design a solution for logging across all the micro-frontends, definitely it's not a great prompt. Even, let's say, create a widget host that loads micro-frontend from a config, handles failure, shows spinner, stuff like that. It's not very meaningful. What we want to provide to an LLM is something that is crystalline clear, that again provides the context that you want to build. So I want to write a TypeScript utility function that loads a remote federated modular runtime. So already with these two lines of prompt, we already have a lot of information. It's TypeScript, we want to load the runtime, a federated module. Then you can define the inputs. I want to pass to this function remote URL, scope, and module. And what are they? And finally, I want to have in return a promise of a React component, so I can use lazy and use that. So as you can see, it's a completely different prompt. It provides like clarity of what we want to have, because if you work in this way, then it became easier to express, especially in critical part of your system, you're maintaining the code that you are building. The other thing is, one thing I found extremely helpful, especially when I have a new feature, is planning first and iterate with LLM, and finally then start to apply into code. So I usually, when I have a new feature or a new big thing that I want to implement, ask for a plan, expressing what I want to have, and then asking for a plan, and then challenging the plan, and maybe have different angles to see the same thing. Maybe because I have some experience that the LLM didn't think about, or I already wrongly provide certain information, so I can tweak before starting to generate code. This is something that makes my life easier. I'm less frustrated, and I can, let's say, share ideas with my code assistant. The other thing that I highly recommend is don't forget to refactor your code. I know that it seems like crazy saying that in 2025, especially for more experienced developers. But the problem is we have seen in this white paper from GitClear that the quality of code started to drop. LLMs are great on building code, like to remove code. And it's very important that we refactor our code in order to make the things better, because there was a drastic drop or refactoring. And that scares me, because I know how much tech debt can impact the performance of a team or a company. These, let's say, suggestions are great for greenfield projects. Framework migration, that is another great thing that we have seen with Micro-Frontends. Recently, people start to use, maybe they have an old Angular application, they want to move to the Angular new framework, new version of the framework, and they use Micro-Frontends instead of going 24 months in stealth mode to iteratively carve out portion of the system into the new system. And they have this middle state that is one or multiple Micro-Frontends, and then they aggregate everything into a monolith again, or they keep like very coarse-grained Micro-Frontend. This is something that I have witnessed, and if you use this approach that I described, it helps a ton. The other thing is modernization. You want to modernize your system towards Micro-Frontend. And again, this iterative approach with what we discussed, it helps a lot. The tip number 3 is accelerating the automation with AI in order to improve your system. There are a bunch of things that I never had time when I was principal engineer and senior engineer in different companies to do, because basically people are dragged until it hurts. Really, it drags to I don't deliver a feature because it's not helpful. But now with LLM, we can leverage their knowledge and their fast generation of code for something that is very meaningful for us. For instance, a question I have every time is how we can handle dependency management across Micro-Frontend. So imagine that you have a shared library, design system, for instance, and you want to, you have a new version, you want to update all the Micro-Frontends. A classic example I usually provide is using Dependabot that is available on GitLab, on GitHub, or anywhere. And Dependabot basically is a tool that scans through your code and says, okay, so in this Micro-Frontend, we are using an older version of the design system. Therefore, there is a new one. So let's create a PR, and tomorrow the developers will find a new PR with the new version of the design system. That works for internal libraries as well as for public libraries. And this is a great approach because you don't have to, let's say, go step by step and look into every single option of Dependabot, but you ask AI to configure that, and then slowly but steadily you tweak what works, what doesn't, and you can ask with natural language what you want to express inside the system. Similarly, you can adopt fitness functions. Fitness functions are a construct that enables you to check objectively the integrity of your architectural characteristics. Let me give you a couple of examples. So one thing that usually in Micro-Frontends you do is keep an eye on the size of an output or a bundle of a Micro-Frontend. You know how to do that. So usually create webhooks that every time that someone opens a PR, you bundle on the fly the Micro-Frontend, check that is inside a certain threshold that you assign. And after that, you are good to go. So if it's inside a threshold, you allow to merge the PR into main, otherwise you don't. This is a classic example that you can easily automate using AI. And even in this case, it's something that is a classic thing, it's nice to have in a system, but in reality, it will help you to protect the decision that you made at the beginning, because vast majority of our systems are there to live for, I don't know, 5, 6, 10 years. And therefore, having these characteristics nailed inside this automation fitness function can help you to go towards the right direction. Similarly, when you want to test your architecture, so there is a library that was a migration of Arc unit in Java to JavaScript. It's called TS-Arc, that enables you to provide certain architectural characteristics. For instance, I want to make sure that in my shared folder for a server-side rendering Micro-Frontends implementation, there are only the header and footer. And thanks to TSArc, you can say, okay, let me write a test that checks that there are only these two functions that are shared only to Micro-Frontends, is unidirectional share, and there aren't any more other, let's say, libraries or areas that are shared. This approach enables you that every time that you run this test for every Micro-Frontend that is, let's say, across the system, or someone that is building the shared library as a private library, will enable you to check that there aren't, let's say, people squeezing in a specific shared module that it shouldn't be, because no one take a look into that. This is a great example, but you can do way more with TSArc. You can also say, I don't want to have any dependencies between Micro-Frontends, so the catalog doesn't have any dependency from home and vice versa. So things like that is something that in the long run, when you're handling a distributed system, and maybe you are changing the developer, so maybe you're using third parties, can be extremely helpful to have implemented. So AI cannot do everything. AI can do a lot, but there are certain situations I find myself that without my knowledge, I couldn't move forward. So a classic example was when I was implementing Module Federation 2 with React Router, because React Router in the past had some challenges with the latest version with Module Federation 1. I knew that. I started to implement Module Federation 2. I started to see some weird behavior, ask AI and my code assistant to fix that. Suddenly, the code assistant proposed a lot of code to basically rewrite React Router in order to make working with Module Federation. That is obviously the wrong path to take. Then I quickly check on GitHub issues if there was incompatibility between the two libraries. It turns out that the latest version with Module Federation 2 in beta, when I tried, didn't work. So I basically revert to an older version of React Router. Everything worked like a charm. But these, if I went through the AI path, would never be picked. Because unless you provide, let's say, clarity in that this specific information was in a GitHub issue and hidden inside, GitHub is not going to surface anytime soon. Therefore, your experience still matters. The other thing is I've seen and noticed that code assistant and LLMs are great to generate code inside a file, so collocated code, but less so modularizing that. Now, that said, all the latest tools for IDE like Kiro or Cursor, JetBrains IDEs, etc., enables you to provide rules on how you want to apply certain things. But again, even if you write them thoroughly and spend time into that, sometimes the modularization is arbitrarily. And therefore, what I tend to do is asking AI to first making something working, like I was doing when I was a developer, and then starting to modularize properly in a certain way that enables me to maintain, let's say, a steering of the code that is generated. Because the other thing that you need to bear in mind, as I said before, AI is great on generating code as well as deleting it. So sometimes you find PR that says, wow, I've just implemented this tiny thing and I have deleted, and AI deleted 1,000 lines of code. So let me see what's happening. You need to be mindful of your cognitive load, because cognitive load is important. At the end of the day, you are responsible for the code that is going to production. Therefore, AI, yes, can generate a lot, can help you to debug issues in production, but at the end of the day, you are responsible for that. So bear in mind this. Because more cognitive load to handle is not always a great thing. So you might feel overwhelmed very quickly. There are some AI use cases that I started to see and works pretty well for me. So rapid prototyping, for instance, I want to check very quickly how to use the latest version of React in a new Micro-Frontend. Great, like with AI, even if the code is not great, it's fully collocated, I can test it very quickly. Blueprints is the same. So if I have a bunch of blueprints or I want to extract certain patterns from an existing Micro-Frontend, I can do that, and I don't have to maintain a blueprint for Micro-Frontends anymore. Testing is another thing that for me is extremely helpful, because if you have, I don't know, unit testing you need to write, or you want to do TDD, etc., you can start to express your context, what you want to test, and then you retrofit the code. You can ask AI also to make sure that every time that you build the new things, it provides, it checks the test, if everything passes, and so on and so forth. So testing definitely is great. And even if you have a testing team that is completely detached from your team, you can ask them to do end-to-end testing independently from you, so they can use AI in order to test things properly and reduce the stress for them and accelerate the production because they are testing more features very quickly. Documentation is another thing that I highly encourage to do. Every time that I build a new feature, I tend to document it, maybe not in the README file every time, maybe have a folder dedicated to that, but the important things I like to express what was the thought process that I had at that specific time. So if I want to go back, I can do that. At the end of the day, is a paragraph or more of content is important. And also it helps when someone is asking, oh, why are you doing this in this way? You can just share, okay, I've written in this way, and that's the reasoning behind that. And finally, UI generation. Nowadays, we have a proliferation of tools that are helping a ton to build UI faster. So even for bridging the gap between your UX department and development, you can use tools like V0, or you can use tools like Lovable or others that enables you to really make your system vivid before you start the implementation. Even a PM, for instance, a product manager, can start to express these things through LLM and say, okay, this is how I want to build it. And it's great because developers have something that can interact with before starting to, let's say, vibe coding. Now, it's very important for me to stress out that all these techniques that I share today are great if you invest time to provide context, because clarity of intent is everything nowadays in this new way to create code and to create systems. If we understand and we write down what we want to achieve and what are the key characteristics for us to express inside the system, the output of these tools will be by far better. Now, if you are interested in Micro-Frontends, you want to know more, I have like a free newsletter that every 10 days or so, I'm going to share one new post with all the latest and greatest that are happening in the community. I'm in a very fortunate position that I know basically everyone in the community, and I heard a lot of great things happening. So I try to share it inside this newsletter. At the same time, in the last 18 months, I rewrite basically almost from scratch the Building Micro-Frontends book that I wrote for O'Reilly, where I change half of the book and update the other half. There are a lot of stories, case studies, and other things that I have seen firsthand with quite a few interesting brands, and I basically collect and put there into the book. So definitely, if you're interested, it's already available for pre-order. It will be available by the end of November 2025. I hope that you enjoyed the talk and it was helpful for you. If you have any question or you want to know more, feel free to reach me out through LinkedIn or X.